All right, let's look at some more questions as part of our preparation towards the SAT math. All right, so question number one, we have a simultaneous equation or a system of equations. All right, and they want us to solve for x. So what we do is we look at the two equations, right? It's nothing complicated. And here, everything is nicely arranged. You notice that there's half y in the first equation, and there's also half y, only it's negative, right? So there are two ways you can go about this. Some people may like to solve for y in the first equation and substitute in the second equation. That's okay. But instead of doing that, you might as well substitute this whole half y, because you notice that half y is the same half y over here, right? So you can pick this one up and say, okay, I'm going to substitute half y in the second equation with 4, which means you're going to have x minus, in place of half y, you put 4 is equal to 2, right? And this one resolves to x is equal to 6, right? So right away, we have our answer as D, right? Alternatively, you can use the method of elimination. That works perfectly if you see, similar terms in the two equations. For example, in the first equation, I see half y, and then the second equation, I see minus half y. If I add these two equations, right away, the half y cancels out, right? So it's going to be something like, here there's no x term in the first equation. So if I add these two, it's going to be x, and then half y minus half y is 0. So let's say x minus 0 is equal to, and then we have 4 plus 2 is equal to 6. Remember, we are adding the two equations, right? And the reason is for the plus in the first to cancel out the minus in the second. So we have our answer. Let's go to the second question. Second question says, if 3p minus 2 is greater than or equal to 1, what is the largest possible value of 3p plus 2, right? So here we are asked to find 3p plus 2, right? Okay, so here we start. We look at these two equations, and we notice that there's a plus 2 here, and there's a minus 2 here. Somebody can do it in one step by just saying that, okay, if I have 3p minus 2 greater than or equal to 1, right? How can I get plus 2 in the equation here, right? I can just add 4 to the equation. One moment. So I erase this. And I say, if I do plus 4 here, and then plus 4 on the right-hand side, what happens? So I'll have 3p, which is already there. And then I have minus 2 plus 4, which is plus 2, right? And this is greater than or equal to, I have 1 plus 4, which is 5. And that's it. I have my solution, because this is what I was asked to find, and this is my answer. So it says, what is the least possible value of 3p plus 2? Least means greater than or equal to, right? So we got A as our answer. All right, so let's go to question number 3. All right, question number 3 says 4 times the number x is added to 12, right? It says when 4 times the number x is added to 12, the result is 8. What number results when 2 times x is added to 7? So here basically we're going to translate this word problem into an equation, right? So 4 times the number x means 4x, right? It's added to, that's a plus, the number 12. The result is, meaning equal to 8, right? And from here, they want us to find 2x plus 7. So this is what we've been asked to do, right? So what we can do is solve for x in the first equation and then substitute in the second. All right, so let's try and do that. So the first equation looks like this: 4x plus 12 is equal to 8. And we try to solve for x, right? So I can use the system of like terms together. I have 3 terms here. I'm bringing all non-x terms to the right. So on the left, I'll have 4x. I have my equal to sign. 8 is already here. If I bring plus 12 to the right side, it becomes minus 12. So with this, I have 4x equals minus 4. All right, and x equals minus 1. All right, and then I just go ahead and substitute this minus 1 into this equation. All right, so if I do that, I'll have 2. I parenthesize it because I have a negative number. 2 multiplied by minus 1 plus 7, right? So it's going to be minus 2 plus 7, which is equal to 5. So our answer is B. All right, let's go to the next question. Question number 4. To make a bakery's signature chocolate muffin, a baker needs 2.5 ounces of chocolate for each muffin. How many pounds of chocolate are needed to make 48 signature chocolate muffins? All right, so here it says 2.5 ounces are needed to make each muffin, right? So it's basically saying 2.5 ounces is equivalent to 1 muffin. All right. So from here, it says how many pounds of chocolate are needed to make 48 signature chocolate muffins. So basically we have here 1 second. So we have here, now we're going to make 48 muffins, and we want to know how many ounces, in other words, pounds, because you've been given what is in this parenthesis to be able to translate, right? But the actual calculation, we do it in ounces because that's easier, right? So if one muffin is equivalent to 2.5 ounces, then what would be 48 muffins? We just have to multiply, right? So it's going to be 2.5 times 48, right? When we multiply this, 48 times 2.5, we get 120, right? So this is 120 ounces. All right. And then the question says 1 pound equals 16 ounces, right? So if 1 pound equals 16 ounces and we have 120 ounces, how many pounds can we get out of that? So basically we take the 120 ounces and then we divide by 16 ounces, right? When we calculate this, we get 7.5 pounds, right? So our answer is A. All right, so let's go to the next question. Question number 5. All right. These kind of questions come up frequently, right? It says an online bookstore sells novels, right? And magazines. Each novel sells for $4 and each magazine sells for $1. If Sadie purchased a total of 11 novels and magazines and have a combined selling price of $20, how many novels did she purchase? Right? Says how many novels did she purchase? So basically, we have to come up with a system of equations between the novels and then the number of the amount the person bought, right? So here we can come up with variables. We can say x and y, or normally I prefer to use the first letter in the items given. So here I will say, okay, the number of novels, let it be n. The number of magazines, let it be m, right? So here right away we see if Sadie purchased n novels, then it's going to cost Sadie a total of 4 times n novels, right? Because each novel costs $4, right? And then the m magazines, each one costs $1. So if she buys m magazine, she's going to pay m dollars, right? So this is how it looks. It says Sadie purchased a total of 11 novels. So here we've established that we have n novels plus m magazines. So we write that down. That's equal to 11. So that's our first equation. N novels plus m magazines equal to 11, right? And we're saying that each magazine costs $4. So with the n, she's going to pay 4 times n, right? Plus with the m number of magazines, if each one costs $1, she's going to pay a total of m dollars for that. And the total of the purchase, both novels and magazines together, is giving us what? $20. So with this, you have your system of equations. Like I mentioned in the beginning, these kind of questions come up. I've seen them in a couple of SAT sample questions. So you need to practice them, right? Come up with your simultaneous equations and then try and solve them. All right, so let's try and solve this. And remember, when you're solving this, focus on the one that they actually want, right? Here they want the novels. So what I would normally do is try to eliminate the one that I do not want, right? What can I do? To eliminate, you normally look for similarities, right? Something which is common to get rid of. Here I see M here, I see M there. So if I subtract the first equation, right? This is the first equation. From the second, what will happen? So basically I'm saying this equation minus the second one, which is N plus M equals 11, right? Right? If I do this, I will have 4N minus N equals 3N. And I'm going to have M here minus M because of this minus, right? So it's going to be crossed out. So let's just say 0. And then I'll have 20 minus 11. Remember, we're subtracting this equation from this equation. So 20 minus 11 is what? 9. So with this, we have 3N equals 9 and N equals 3, right? 3 times 3 is equal to 9. So our answer is B, right? So pay attention to these questions, right? Question number 6. All right, we have 2 equations here which are equal, right? But in the second one, we have coefficients or constants which are unknown, and we're trying to find one of them. The way you deal with a question like this is you try and expand what can be expanded and simplify it, and then try and compare coefficient by coefficient, right? Coefficient means the number attached to the variables. So in this case, the coefficient of x squared on the right is A, right? The coefficient of x on the right is B, and then we have a constant C. So let's try and do this. So on the left, we have 2x in brackets 3x plus 5 in brackets 3x plus 5, right? And then on the right, we have ax squared plus bx plus c. So let's focus on the left-hand side. Let's expand. 2x plus times 3x is what? 6x squared. And then 2x times 5 is equal to what? Plus 10x. Then we have plus 3 multiplied by 3x is equal to what? Plus 9x. And then we have plus 3 multiplied by 5 will be equal to what? Plus 15. And we're saying this whole thing is equal to ax squared plus bx plus c. So let's try and simplify the left-hand side. So left-hand side, we're going to have 6x squared. 10x plus 9x is what? 19x plus 15. And this is equal to that, right? So like I mentioned before, just compare coefficient by coefficient once you have it written with the same number of terms, right, as the one you're comparing with. So here we can easily say that A is equal to 6, B is equal to what? 19, C is equal to 15, right? So the answer we're looking for is B, right? So if you're able to work it like this, the answer could have come in any shape or form. They could have asked you what is A plus B, or what is A times B, or, you know, it doesn't matter. Once you have this established with the same number of terms, you just, you know, it just becomes clear which is which. All right. Okay, let's go to the next question. Question number 7. So question number 7 is showing similar triangles, 2 similar triangles, right? With this kind of question, it's easy, right, to see what's going on. First thing you have to know, and they gave it to you, it says CD is parallel to AE, right? If that's true, then it means the angle here, angle at D, is equal to angle at A, right? Because you see a Z, right? In one of my videos, I mentioned the way to look for angles is to, you know, look for a few shapes, right? Look for Z, you look for X, you look for straight line, you look for a triangle, you look for a right angle, and everything will come together, right? So here we see the ratios. We see 10 to 5 and then 8 to something, right? This gives us the what do you call scale factor, right? So it's going to be 10 is to 5 as 8 is to question mark, right? And here you can easily see that it's half, right? 5 is half of 10, so the number here should be half of 8. All right, so our question mark here is going to be 4, right? So you just, you know, establish the ratios, right? Now, if you want to use angles, right? Normally, if the shape is not like this, if they were to be separated and you want to know, you know, the similarities, remember, the fact that it's drawn, you know, let's say sitting side by side would not necessarily mean that they are similar. I have a way to look for similarities. I say follow the angles. Right? Follow the angles and then use the corresponding sides, right, to establish the scale factor, right, or the ratios, right? So let's say if we were to do this over here and we want to follow the angles, let's name the angles. Let's say this is angle 1 and this will also be angle 1. This angle here is going to be this because that's also a Z, right? Because CD and AE are parallel, so that's also a Z. So here we have, if this is angle 2, then this would be angle 2. What about angle 3? This angle 3 is the same here because it's opposite angles, right? Or it forms an X, right? So knowing this and seeing where the angles are, I see angle 1, 2, 3. So if I'm going to name the triangles, I'll go 1, 2, 3. This is what I mean. So I would say triangle A, E, B, right? This is where the triangle ends. It's similar to triangle. Remember, I said follow the angle. So we're following 1, 2, 3. So it's similar to D, C, and B. And you notice that because I follow the angles, the letters don't necessarily follow. Very important. Once you are able to do this, you can pick any pair, right? Any pair of the letters and say that their ratios are equal. What do I mean? What I mean is I can say that AE over DC is going to give me the scale factor, right? Or I can continue to say that if that's true, then AB over DB is also going to give me the scale factor. And now you can just look, right? We have AB is 10, and then BD is what? BD is 5, right? So this is 2, right? So if we want to look for, let's say, the BC from this same, follow the angles, right? We see BC here, CB here. So we're going to use BE or EB, right? Once you naming the lines, it doesn't matter how you name it, but the triangles are very important. Follow the angle. So here I will say EB over CB or BC is also equal to 2, right? So in this, I know B or EB, right, to be 8, and I want to find CB, right? So CB is going to be 4. So 8 divided by 4 is going to be 2, right? I took the time to explain this because similar triangles, very easy to do as long as you follow this rule. Follow the angles. And it applies to all, similar figures. All right, let's go to the next one. So question number 8. Question number 8, we have a circle, right? In the circle above, segment AB is a diameter. So that's segment AB. And the diameter, remember, it passes through the center of the circle, right? And the diameter is made up of, twice the radius, right? The radius is from the center to any point on the circle. The diameter is from one point on the circle through the center of the circle to the opposite end. All right? If the length of arc ADB, here's the arc ADB, right, is 8 pi. What is the length of the radius of the circle? And we can see that ADB is half of the circumference, right? We can easily see. They want us to find the radius, right? So this is what we've been asked to do. So let's go with what we know. We know that circumference is equal to what? 2 times pi times r, right? That's a formula that we know, right? And here it says ADB. ADB is the arc. So arc ADB is what? It's half of the circumference. We're given as 8 pi, right? But we know the whole circumference is 2 pi r. So half of it, which should also be equal to this, is going to be what? So we divide 2 pi r by 2, and we're going to be left with pi r. All right? So basically, we're saying that 8 pi is equal to pi r, right? Because they are the same. So we can divide by pi. So pi here cancels pi here, right? And our 8 is equal to r. In other words, r equals 8. So C is our answer. All right, so this is very simple. We want the radius. We look at this. It's half of the circumference. We write down the general formula for the circumference. And from there, we just continue, right, with the information we know. We know half of the circumference as 8 pi, which is given. Our formula says half the circumference is pi r, because we divide by 2. And then from there, just, look at the two sides. Okay, question number 9. Question number 9. It says a radioactive substance decays at an annual rate of 13%. Right? I know a question like this, if you are not interested in science, it's kind of going to stress you out a little bit. But the only thing you need to worry about is the radioactive substance. It loses its potency, right, with time. So that's basically what they are saying. And here they're saying that it decays, right? It decays means it loses the potency, at a certain rate. It says at an annual rate of 13%. If the initial amount of the substance is 325 grams, which of the following functions F models the remaining amount? Remember, this is the key. The remaining amount of the substance in grams T years later. All right? So here we are interested in what remains, right, with time, not the decayed amount itself, but what remains. So here, with the percentages, if you losing, right, you have to subtract from 100%. If you gaining, you have to add to 100%. So if it's decaying by 13%, it means we'll be left with what? Left with 87%, right? Which is equal to 0.87, right? So that's the amount that will remain, right, each year after the decay, right? So here, the way you normally, or I would normally solve a question like this is, I test, right? So I would say, okay, I write my function, and I would say, okay, f of t equals, I don't know yet, but what I know is it's going to be 325, right, multiplied by 0.87, right? And then let's say I replace this t by 0, right? When it's 0.87, right? So for now, I don't know the time. So let me better put, we know the final function is going to be f of t, but the way you test it is test with, numbers. Start with small numbers. So I'll say, okay, after 1 year, this is what will remain, because it says it decays at the rate of 13% each year, right? So at the end of 1 year, I'll have 3.25 multiplied by 0.87. That's what will remain of the total. Now let me go to second year. Remember, for the second year, I will have to use what remained after the first year and then multiply by 0.87 again, because it always, decaying based on where it started from, right? So I'll have 325 multiplied by 0.87. So all this was from the first year, and then multiply by how much is remaining after decaying by 13% one more time. All right. So with these two, we've seen a trend, but let's do a third one so it's clearer. So after third year, what do I have? I'm going to have this whole remaining amount from the second year decaying by 13%. So I'll have 325 multiplied by 0.87 multiplied by another 0.87. All this is from what? The second year. And now at the end of the third year, I have a decay of 13%, leaving me with 87%, right? So what do we see here? First year, we have 87. Second year, we have 0.87 multiplied by 0.87. Third year, we have, this repeating 3 times. So it shows us that the trend is at the end of t years, we're going to have our original multiplied by the number of years, raised to multiply by 0.87 raised to the number of years that have gone by. Remember, this is the third year. We see this appearing 3 times. Second year, it appeared 2 times. First year, it appeared only 1 time. So it's going to be, right? So A happens to be our answer, right? Just go over this again. Whenever you see questions like this, test it, right? With a few, steps, right? After 1 year, after 2 years, after 3 years, and then see how the trend goes, right? And also the key point is know what they are asking for. Here it says it has decayed by 13%, and they want what is remaining, right? If they were to ask to find, how much it has decayed by, then we will worry about, using this. But they want what is remaining. All right. Okay, let's go to the next question. Question number 10. Okay, so question number 10, it says in the equation above, A is a positive constant, and the graph of the equation in the xy plane is a parabola. Which of the following is an equivalent form of the equation, right? So we look at this. What you do is look at the question and you scan through the answers, right? And you notice that this is looking like the difference of 2 squared numbers or 2 squared quantities, right? And if we look at this, this certainly cannot be the answer, because this represents difference of two squares, but this will actually be x squared minus a squared, which is different from this. Now, if we go to the second one, this is also difference of two squares, and this is what? X squared minus parenthesis square root of a squared, which is actually x squared minus a, right? So just like that, we found our answer. If we want to use the third one or test the third one, we notice that it's not true, right? Because if you square a over 2, it's not going to give you minus a. It's actually going to be a squared over 4, right? And the last one is not the answer either. So this is the answer. So what did we do? We looked at the question and we looked at the answers that they're expecting, right? And then we just have to rewrite it. You know, this is my advice to those preparing to take the SAT. Difference of squares or difference of two squares. You have to know the formula. Know it, practice it, be aware of it. You will almost 80% get a question that relates to difference of two squares in some shape or form. So be aware of that, difference of two squares. And it's pretty easy to, remember. The difference of two squares. Right, we know the formula. We say a squared minus b squared is equal to a plus b, a minus b. So you either see the question, where the right hand side is given, and you have to remember that it's equal to the left hand side, or the other way around. And they are fond of, throwing in the square root, but know that if you square a square root, it just releases the square root. So this is a, right? So this is also true. Okay, let's go to 11. Okay, 11, we have this triangle, and they want us to find the length of AD, right? Here, we have to establish a few points. We have 60 degrees here. We have this symbol here, which is a symbol of right angle. So it's what? 90 degrees here, right? So this is 90 degrees, right? So what's the angle here, right? We know this is a triangle, right angle triangle, BDC. So this is going to be what? 30 degrees. The total internal angle of the triangle is what? 180 degrees. So if this is 60, this is 90, then the remaining angle is going to be 30. So with that, we're able to see that this whole angle here is what? 60 degrees. If that's true, then it means this is also what? 60 degrees. And the question is, almost solved, right? We know that if we have, 60 degrees angles, then it ends up to become an equilateral triangle, right? So equilateral triangle, all the angles are 60 degrees and all the sides are equal, right? So it means that this side 12 is the same as side 12 here, AB, and the same here. And D happens to be at the center of AC. Why? Because it's this line is perpendicular, right? The only way you can make that is to meet it at the midpoint. So if AC is equal to 12, what is AD? 6, right? So, we just, looked at the angles, established, what the angles are, and then use the information given. All right, let's move on to question number 12. Question number 12. The surface area of a cube is 6 in brackets a over 4 squared, where a is a positive constant. Which of the following gives the perimeter of one face? So we're talking about a cube, right? So a cube looks something like this. Right? Where all the surfaces are squares, right? So this surface here is a square, 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 square. And here we can see that the cube has how many faces? 6, right? It's like, a dice without those, numbers punched on them, right? So here it says the surface area. It means the surfaces. We found the areas, right? And since there are 6 of them, we have 6 times something, right? And here we've been given a over 4 squared. So that tells us that the surface area for each of the squares here is what? So surface area for each square surface is what? It's going to be a over 4 squared. And since it's a square, and we know area of square is what? The length times the width. Length is equal to width. So it means that each side is what? A over 4, right? Because a over 4 times a over 4 will give us this. So basically we're trying to find, to get the perimeter, we need to know the length of the sides, right? So each side is what? A over 4. So a over 4 here, a over 4 here, and a over 4 here, right? So to get the perimeter, you just add them. Remember, definition for perimeter is what? Distance around, from the edges. Distance, around the figure on the edges. Here we are only considering one surface. So if you start from one point here, you just go 1, 2, 3, 4. So our answer is a over 4 plus a over 4 plus a over 4 plus a over 4, which will give us a, right? Because when we add all these, we're going to end up with 4a over 4. 4 cancels out, and we get this. So understand this, right? In case a question comes and they don't ask you, to find the perimeter this way, right? Maybe they want you to find, the perimeter for as long as you can travel on the edges, right? Then you just stand on one corner and then just start moving until you cover all the edges. All right, let's move to the next question. Question number 13, right? 13 says, the mean score of 8 players in a basketball game was 14.5 points. The highest individual score, if the highest individual score is removed, the mean score of the remaining 7 players becomes 12 points. What is the highest score, right? So here we have to establish what? The mean, which is also called average, right? And we know the mean is going to be what? Total over what? Count. Right? This is the simplest way I would normally put it. Total over count. So in the first instance, we've been given that the mean was what? 14.5. Right? From that, we can find the total, because we know there's a count of what? 8 players. Right? So from here, the total is what? It's going to be 14.5 times 8. 14.5 times 8. And that gives us 116. And then we're given a situation where the highest individual score is removed from this set, right? Remember, it's from this set. So the total is no longer going to be 116. 116 is for the 8 players, right? Now we have 7 players. Okay. Now it says the mean for the 7 players. So using the same formula, we have 12 is equal to total. We are now totaling for the 7 over what? 7, right? So from here, total is equal to what? 12 times 7, which is equal to what? What is 12 times 7? 84, right? So 12 times 7 is going to give us 84. Sorry. So 12 times 7 is 84. All right. And now we just find the difference, right? This is the total when all the 8 players were involved. This is the total when the highest scoring player was removed. So to find the highest scoring point, we just have to find the difference. So it's going to be 116 minus 84, right? Which is going to be 32 in our case, right? So it's C. All right, let's move on to the next question. All right, so here we have a line PS from end to end, PS. And then in between we have these points and segments, right? So it says on PS above, PQ is equal to RS. What is the length of PS, right? So it says PQ is equal to RS. So here you don't have to sweat it. Just write it down the way they have it, using the X values. So it says PQ, we know PQ to be what? X minus 1. And it says equal to RS. is what? 3x minus 7, right? So this is an algebraic equation we can solve, right? So, and the actual ask, or what they want us to do is to find PS, right? And PS is going to be what? All this, you have to add all the known lengths, or with the variables. So it's going to be x minus 1 plus x in the middle plus 3x minus 7. So all this gives us our px, right? So what do? We just go ahead and find the value of x from the first one. So let me bring the calculation here. So we have x minus 1 equals 3x minus 7, right? So here, if I arrange like terms together, for convenience, I want to bring all x's to the right and all non-x's to the left. So on the left, I will have minus 1, which is already there. And then minus 7 comes over, it becomes plus 7. On the right, I already have 3x. I bring plus x over here. When it crosses the equal to sign, it becomes what? Minus x, right? And I just count. I still have 4 terms. That's very important. That way, you haven't left anything behind, right? 4 terms we started with, 4 terms we ended. We end with after we rearrange the terms, right? Minus 1 plus 7 is what? 6. 3x minus x is what? 2x. So x is equal to what? 3. So now we can substitute x in this, right? So I have 3 minus 1 plus 3 plus 3 times 3 minus 7. All right? So here, 3 minus 1 is what? 2 plus 3 is what? 5 plus 9 is what? 14 minus 7 is equal to 7. Right? So our answer is 7. Remember, this is what we were trying to arrive at, right? So remember, the answer here is not x. The x we calculated over here. This value here is now the whole length, right? Okay, let's move on. Question number 15. Okay, question number 15. It says in the xy plane, the point 2, 5 lies on the graph of the function f. If f of x is k minus x squared, where k is a constant, what is the value of k? And remember, when you see this, the first one represents x, second one represents f of x, right? Or you can say y. Right? It depends on how the question is put, right? So here, if it says this point lies on the graph, another way we put it is it satisfies the equation of the graph, meaning that it makes it true, right? It's part of the graph, all right? So what you do is you just substitute the point given into the equation, right? In place of f of x, which is now going to be f of 2, we know f of 2 is going to be 5, right? So let's just put the number. So 5 for f of 2 is equal to k minus, and then in place of x, here we put 2, right? And then we solve for this. 5 is equal to k minus 4. Remember, the minus still remains because, you know, we put x in parentheses and then substituted the 2, right? So from here, we see that 5 plus 4 is equal to k. K is equal to 9, right? And we are done. Okay. 16. So 16, we have a circle. We've been given some angles. And then they want us to find this angle, x, right? P is the center of the circle, right? Just remember that the total angle at the center of the circle is going to be 360 degrees. Meaning if we take the radius and then move it all the way around to the same point, it will cover 360 degrees at the center. All right? So let's see what to do with this. So we have 20 degrees here, right? From P to B is the radius, right? The radius can be anywhere. Also remember, from A to P is also the radius, right? Let me see if I can make this happen. Yeah, we got it, right? So A to P is the radius, as well as P to C is the radius. So with this, we can see that on top here, we have a triangle with these two lengths equal. What do we call that? That's isosceles, right? So with the isosceles triangle, we have two sides equal and then two angles equal. So that means this angle here, messed up. Let's try again. Right, this angle here is 20 degrees. Means this angle here is also going to be 20 degrees because these are going to be, you know, similar triangles, right? Because this is the radius. AP is a radius, right? So I was saying that since this angle is 20, that angle is 20, we will be able to find the angle over here, right? Because this is a triangle. So 20, 20, this has to be 140 degrees, right? That's the angle between the, you know, two radius, right? And if that's the case, then it means this angle is also going to be 140 degrees, right? Why? Because we have a triangle with two angles being 20 degrees, 20 degrees here, 20 degrees there. So to get the 180, we have to add 140. And I started by saying that the total angle at the center, right, of the triangle is what? 360, right? So out of the 360, we have what? 280 of it, right? So we have 360 degrees, which is the total, minus 280 degrees. That will be what? That will give us 80 degrees. So our x is equal to 80 degrees, right? So just pay attention to this. Look at the radius, right? The radius tells you a lot because the radius is always from the center. Once you're able to establish that, no, the radius is going to be the same length no matter where it is, right? So that's how we're able to tell that these two lengths are the same. AP and BP are of equal lengths, right? If they are equal, then we right away have an isosceles triangle. So we can establish that the angle at A with respect to APB is what, 20 degrees. And we do the same thing for APC, right? The radius, carries the weight. All right, let's go to the next question. (17). Okay, 17 says the weight of an object on Venus is approximately 9/10 of its weight on Earth, right? So on Venus, it weighs 9/10 of the weight on Earth, right? Which we don't know yet. We will read it. The weight of the object on Jupiter. So on Jupiter, it weighs 23/10, right? Meaning the same object will weigh more on Jupiter than on Venus. It says if the object weighs 100 pounds on Earth, approximately how many more pounds does it weigh on Jupiter than on Venus, right? So here we're going to find a difference, right? So here, 9/10 of the weight on Earth is what we're going to find, right? This is going to be what? It's going to be 90, right? All we do is replace the off here with the multiplication sign, right? And then solve it. So it's going to look like this: 9/10 of 100, which is equal to 10 cancels out, and 9 times 10 is 90, right? So this is 90. We do the same thing for this. So this is times the same 100, which is the mass on Earth, and this cancels, we get 230. And they want us to find, the difference, right? It says by how many more pounds does it weigh on Jupiter than on Venus. So we find the difference. So it's 230 minus 90, right? 230 minus 90 is what? I think it's 140, right? So it's going to be this. 230 minus 90. Yes. All right. So this is an easy question. Just look through again. Make sure you understand how we did this. That way, if they ask a similar question in the future, you know how to go about it. All right, let's go to 18. All right, 18 is straightforward. It says 3 in brackets C plus D equals 5. What's the value of C plus D? Here, we don't have to struggle. We don't have to, complicate anything, because we know that this is the ask and it's here, right? So all we have to do is what? Divide the left side by 3. So we have here 3 C plus D equals 5, right? So we divide the left side by 3, just so C plus D stands alone. And we do the same thing on the right hand side. Whatever you do on the left, do on the right. Whatever you do on top, do to the bottom, right? So C plus D equals 5/3. Don't try to expand or do anything. That will be another step. That doesn't lead you anywhere. You'll be stuck, but you don't have to be, right? The questions, give you a lot of clues. Some questions are very straightforward, right? They just want to, check out how, you look at things. So this is our answer. Let's go to number 19. All right, number 19. It says here, the density of an object is found by dividing the mass m of the object by its volume v. So we got three variables, d, m, v, just like the motor vehicle. Which of the following equations gives the mass m in terms of d and v? Right? So first of all, we have to establish the original equation, right? It says the density d is found by what? Dividing the mass by volume. So this is the original. And then they want us to write m in terms of d and v, meaning that make m the subject of the equation. That's all that means. All right? Make m the subject of the equation. How do we make m the subject of the equation? You just have to multiply each side by v. So this v cancels that. And this is our answer. So we got A. Right? So you see here, there's no struggle. Just take your time and then establish what they're looking for. All right. Question number 20. All right. Question number 20. It says here, Maria plans to rent a boat. The boat rental costs $60 per hour, right? And she will also have to pay for a water safety course that costs $10, right? Maria wants to spend no more than $280. So Maria wants to spend less than or equal to $280 for the rental and the course. So she's doing two things. If the boat rental is available only for whole number, so let me underline this, whole number of hours. What is the maximum number of hours for which Maria can rent the boat? So first of all, let's try and establish the cost of doing all this. Boat rental costs $60 per hour, right? So let's come up with a variable for the hour. We can use T, we can use H, we can use X. So it depends on, which one you're comfortable with. So I'm going to use T in this. So I'm going to say, okay, Maria rented the boat for T hours. So in that case, Maria will spend 60 times T, right? Plus the $10 for the course, right? If Maria rents the boat for T hours, since each hour costs $60, she's going to spend $60 times the length of time plus the cost of the course that she'll have to take. And this is supposed to be less than or equal to $280 because she doesn't want to spend more than that. All right. So with this, we can see, or we can go ahead and calculate, right? We have 60t is less than or equal to 280 minus 10. Right? All I did was bring the 10 over here to the right. That's why it became minus. Right? So 60t is less than or equal to what? 270. Right? We can cross out the zeros. Crossing out the zeros means divided by 10 each side. Right? And then we have t is less than or equal to 27 over 6. Right? We divide by 6 so that the t stands alone. All right, so here we have 3 here is 2, 3 here is 9. So this is going to be 9 over 2, which is 4.5. Right? So it means our t is less than or equal to 4.5. And the condition given to us is that the hours or the time should be whole numbers, right? Here we cannot approximate it to 5 because then she will end up spending more than 280. So we have to approximate it down. So t is equal to what? 4, right? So 4 is the maximum number of hours for which Maria can rent the boat, right? And this is for whole number of hours. All right? Okay. Practice, practice, practice. That's all I can say. Thanks for listening in.